Alright, let's start this by just doing a quick review on solving systems by substitution. Remember, with substitution you have to solve one of the equations for one of the variables. And in this case, either of these would be equally as easy. So I'll solve for x by subtracting y from both sides. So now I have x equals negative y plus 18. I'm going to take this and substitute it in for x because now I know that x equals negative y plus 18, so I can drop it in for x. So that will look like 2 times negative y plus 18 plus 3y equals 44. Then I have to use the distributive property, negative 2y plus 36 plus 3y equals 44. And then I have to combine my terms, so y plus 36 equals 44 minus 36, very tedious. So y equals 8. And then we have to take this, plug it back in up here, so now I have negative, I'll do it up here, negative 8 plus 18 equals 10. So remember, our solution to a system, unless it is a special system, is that ordered pair, 10, 8. We need to check it though. So this one is easy, 10 plus 8 is 18. But this one, 2 times 10 plus 3 times 8, does that equal 44? And it does. 20 plus 24 is 44. That checks out. This is our answer. But very tedious. For some equations, there is an easier way to solve a system besides graphing or substitution, and it's by combination, or I'm going to put another word up there, elimination. You see elimination just as often as combination these days. So if you are needing to Google it for more help, you can say solving systems by combination or elimination, and you should get some good hits. As always, I suggest you pause and write these steps down, so that way you're not trying to write the steps and do the problem with me in your notes at the same time. Alright, so step 1, arrange the equations with like terms in columns. Most times this is already done for you, but you need to make sure that the x's are in one column, the y's are in another, and then the numbers. In other words, they're probably going to be in standard form, although sometimes your leading coefficient will not be a positive. So after you have them in like columns, the next is making a y's next step. And to do that, you have to study the coefficients. You want to look at what the coefficients are for each of the variables. So here I have a 1 and a negative 1 and a 2 and a 1. Okay, so you're going to study them because what you're looking for is this right here. You want opposites because you want to cancel out or eliminate one of the variables by combining the two equations. So you're wanting opposites. So when you're studying, what you're really looking for are opposites. And in this case, we are very lucky for this first one because right here, 1 and negative 1 are already opposites. And because they're opposites, when I can combine them, in other words, when I add the two equations together, these cancel out. X plus negative x cancels out. And then we can combine going down. So 2y plus y is 3y. So let me go back over here. So this is this step 4. We did not have to do this step. Also, I'll talk about that in a little bit. We didn't have to multiply one or both equations by an appropriate number because we already had opposites. What we're doing now is adding the two equations together. So 2y plus y is 3y, 24 plus 0 is 24. And then we're going to solve for the remaining variable. We just canceled out one of the variables right here because they were opposites. We're left with one variable, so we can solve just like we did back in the solving equations unit. So y equals 8. And then, so our ordered pair, we know our y is going to be 8. Then you can plug this value back into one of the equations. It does not matter which one, whichever one is easiest, to solve for the other variable. So we know what y is, we're trying to find x. I'm going to use this first equation right here. So I'm going to do x plus 2 times 8 equals 24. So minus 16 minus 16. So x in this case is also 8. But don't forget the almighty check step. There's so many places to make mistakes in these systems that you want to check your work. So I'm going to use the first equation, 8 plus 2 times 8 does indeed equal 24. And then negative 8 plus 8 equals 0. So both of these check out, so I know we didn't do any arithmetic errors. Alright, so let's do another example. First thing we're going to do is arrange them in like columns. So my x is in one column, my y is in another, my constants in a third. That's done for us. So then we're going to study the coefficients to make a wise next step. 8 and 5 are nowhere close to being opposites. They're both positive, and it's not an easy fix. This one, however, the 2 and negative 1. 2 and negative 1 are not opposites yet, but they're at least opposite signs. And all I would need to do to make them opposite is to multiply this y by 2. But remember, this is an equation. If we multiply this by 2, we need to multiply everything in that equation by 2. And that is the number one mistake that people make with this type of solving systems. So we need to multiply everything by 2. So I'm going to do the distributive property, but over the whole equation. So 5x times 2 is now 10x. 2 times y is 2y, but it was minus. And 2 times 28 is 56. Alright, so from there, I'm just going to rewrite this equation down below. So 8x plus 2y, making sure my columns line up, equals 16. So I studied. I multiplied one. We only needed to multiply one of the equations by a number to obtain opposites, which we did. And remember, we multiplied everything and that equation by 2. Next, we have to add and solve for the remaining variable. So 10x plus 8x is 18x. My y's canceled out, and on this side I was left with 72. So I'm going to divide by 18. I'm going to divide by 18. So x is 4. So I'm going to come over here and I'm going to write what I think is my answer, 4, for my x. Now, the next step is substituting that value in, this 4, into either one of these, wherever it's going to be easiest. I'm going to just plug it into the first one for the sake of this. So 8 times 4 plus 2y equals 16. So 8 times 4 is 32, so I'm going to subtract 32. So now I have 2y equals a negative 16. So y is a negative 8. We think. Again, can't tell you enough the importance of the check step. So the first one, 8 times 4 plus 2 times negative 8. That's 32 plus a negative 16 does equal 16. That one checks out. And 5 times 4 minus a negative 8. That should equal 28. So 20 plus 28 is 28, so we know that we did this correctly. Alright, last example, and even if you think you're getting it, I suggest you watch this last example only because it's a little trickier. If you look at, so first they are arranged in like columns, but if you study, 4 and 10 are not close to being opposites. We would have to multiply the first common denominator, or the first common multiple, I should say, would be 20. We could multiply this by 2 and this by a negative 5 maybe. And then 6 and 7, they're at least opposite signs, but again, we would have to multiply both numbers by something to make them opposites. In this case, we'd have to multiply the negative 6 by 7 and the 7 by 6. So I think that's the one I'm going to do. If you chose to do the 4 and the 10, you should come out with the same thing. And you might want to try it just to see if you come out with the same answer. All right, so I'm going to multiply this whole first equation by 7 and the whole second equation by 6. So then I have 28x minus 42y equals negative 42. And then when I multiply the second equation by 6, and again I'm remembering to multiply every single part of that equation by 6, I have 60x plus 42y equals negative 24. All right, and so then when we combine down, when we do this fourth step, add, we have 88x, the y's cancel out, equals negative 66. And you can see at this point some of you will be going, oh, we must have done something wrong because I'm coming up with a fraction. Remember, fractions are not evil. I mean, some of you think they are, but all right, negative 66 over 88 comes out to negative 6/8, which is negative 3/4. So I think that my answer for x, the x-coordinate, is negative 3/4. So the next step is to substitute it back into either one of the equations. Well, I don't like working with fractions, even though I just said they weren't evil, so I'm going to choose this first one because I can see that the denominators will cancel out. So I'm going to do 4 times negative 3/4 minus 6y equals negative 6. My 4's cancel. I'm left with negative 3 minus 6y equals negative 6. Add 3, so negative 6y equals negative 3. Divide by negative 6, so negative 3 over negative 6. So it looks like y is also fraction 1/2. So anytime you get a fraction, I know that you guys are thinking, must have done something wrong. Make sure you check, even if you don't get a fraction. So I'm going to check both of my equations. So I have 4 times negative 3/4 minus 6 times 1/2, and I'm hoping that it equals a negative 6. My y's cancel, so I have negative 3 minus 1/2 of 6 is 3. So negative 3 minus 3 is a negative 6, so that checks out. So now we just have to do the next one. 10 times negative 3/4 plus 7 times 1/2 should equal negative 4. So here, I'm going to change colors. We can cancel, 2 goes into 4 2 times, it goes into 10 5 times. So I have 5 times negative 3 is negative 15 halves plus 7 times 1/2, I'm just going to leave it in halves, equals negative 4. Some of you probably would do the division, and that's okay. You can put it in decimal form as long as it's not a repeating decimal. So negative 15 plus 7 is a negative 8. Negative 8 halves does equal negative 4. That checks out. So that is our answer.